And that's all. Now, continuing along, notice if both the major and the minor axis have the same radius, meaning that the denominators on the x's and the x squareds and the y squareds end up being equal, then, well, what does that mean? If the radius for the x's and the y's are the same, then it's an actual circle, not an ellipse. Now, with ellipses, we have a special term. It's called the eccentricity. We use the letter E for eccentricity. And the formula for ellipses for eccentricity is equal to C over A. And again, remember, A is the radius of the major axis. And when we say C, we're still using the C from C squared equals A squared minus B squared, which, remember, if you wanted to solve that for just C, you would take the square root of both sides. So C would just equal the square root of A squared minus B squared. So what we can do is, given an ellipse, it doesn't even need to be in standard form, we can find what's called its eccentricity by finding C over A. But in order to find C over A, it needs to be in standard form. It's a whole lot easier. Well, standard form looks like the following, where you have, let's see, it looks like the following, where you have x minus something or plus something squared plus y plus or minus something squared over, you have something squared, and equals 1. So our original formula looks nothing like that. So first of all, get your x's and y's on the same side. We'll do that by going ahead and adding the 25y squared to both sides. That'll at least get the x squared and the y squared on the same side. Well, then the next problem is that the right-hand side will equal 100, not 1. We want it to equal 1. It equals 100 now, so how do you get rid of the 100? You'll divide both sides by, everything on both sides, that is, by 100. Well, then notice on the right-hand side, the 100 divided by 100 will get you 1. That is wonderful. We have to see what happens with everything else, though. Well, on everything else, you just have to reduce. So, for instance, you'd look at the 4 over 100 and reduce that like a normal fraction, and it reduces to 1 over 25. The second fraction, let's see what we've got, is a 25 over, 100, which reduces to 1/4. So, remember, A ends up being the radius on the major axis, which is the biggest. So, well, that's going to come from the 25, which means that's where, remember, it's already squared, so that means that that side is your A squared, which means your A is just 5. Means the other one is your minor axis, is your B squared, which means B is just 2. Well, problem is to find eccentricity. Remember what the formula is. The eccentricity formula is E equals C over A. Well, we've got A and we've got B. We don't have C. We need to find it. Well, let's use our formula for C. Well, the formula for C is that C squared equals A squared minus B squared. So C squared equals A squared minus B squared. Well, we said our A is 5. So A squared will be 25. We also found out our B was 2. So B squared will be 4. So then when we subtract the 2, we get, we get 25 minus 4 is 19. Be careful, though, that gives us C squared. So if we want just C, we're going to have to take the square root of both sides of the equation, which then gives us that just regular C is equal to, by taking the square root of both sides, square root of 19. And 19 is a prime number, So you're stuck. You can't do anything with that. So remember, the formula for eccentricity is C over A. Well, we just found out C is the square root of 19. And we already knew what A was. A was 5, so we can plug that in on the bottom. So the eccentricity will be square root of 19 over 5. That's a perfect answer, as long as the square root is not on the bottom. So we'll leave it just like that.